Now that we know what the normal distribution is and have some idea of how to work with it, we're going to use what we talked about in the last section to answer some real world, or at least pseudo real world type questions. There are two kinds of problems in this section. One where we're asked to find the probability, or the percentage, or the proportion for a certain range of values. And then another where we're kind of doing the opposite of that. We're finding the range of values, or the cutoff score, for a certain percentage. So first let's talk about the first one of those, where we're going from a certain range of values to finding the probability, or the percentage. An example of this kind of problem would be the heights of all the flowers in a meadow are normally distributed. The mean, or average height, of the flowers in the meadow is 15.5 inches, and the standard deviation is 2.2 inches. You go out into the meadow and you pick a flower at random. What's the probability that the flower you pick is over 15.5 inches tall? So notice we're told that the mean is 15.5 inches, and the standard deviation is 2.2 inches. And when it asks what's the probability that the flower you pick is over 15.5 inches tall, that's just asking what's the probability that it's above average. And if these flowers do have heights that follow a normal distribution, it's symmetric, so half the flowers are above average and half are below average. So if half of the flowers are above average, that means 50% of them are over 15.5 inches tall. So the probability of the one you picked being one of the ones that's over 15.5 inches tall would be 50%, or 0.5. Now, we didn't really have to do any calculation for that because the number it asked about was the average. But what about something like this? You pick a flower at random. What's the probability that the flower you pick turns out to be over 17.5 inches tall? So, out of all the flowers in the meadow, some of them are more than 17.5 inches, and some are less than that. And we're kind of pretending there aren't any that are exactly 17.5 inches, because if you found one that you thought was exactly 17.5 inches, you could measure it really, really carefully and find that it was really just a tiny fraction of an inch either above or below that. So we're assuming that everything is either more or less than 17.5, and we want to know what's the probability of getting one of the ones that's more than 17.5, or what percentage or what proportion of all of them are more than 17.5 inches tall. So here's how we could write this. We're looking for P, that is the probability, or the percentage, or the proportion of our random variable, the randomly chosen flower height, being greater than 17.5 inches. So we want the probability of our random variable x being greater than 17.5. That's what we need to find. So how do we find this? Well, there's two methods, or two ways of approaching this. One way is to change this into a question about z-scores. What is the z-score for 17.5 inches? Now remember, we first learned about z-scores and how to calculate them back in chapter 3. The formula for z-scores is z equals x minus mu divided by sigma. So that means we take this number for x, we subtract the mean, and then we divide by the standard deviation. And if you're putting this into your calculator, remember that you do need parentheses around the subtraction part so that it knows to do the subtraction before the division. So if we ask our calculator for 17.5 minus 15.5, which would be 2, divided by 2.2, it comes up as 0.909090 and so on, repeating. And I'm going to round that to the nearest hundredth. If you remember, the table that we were working with last time had z-scores out to 2 digits after the decimal point. So that's what we're going to work with in terms of the z-scores. We're going to round it to 2 decimal places. So a 0.909 something rounds to 0.91. So now we have to find the probability of z being greater than 0.91. We've transformed a question about flowers and their heights into a question about z-scores and the standard normal distribution. So the x that stood for the height of a randomly selected flower got replaced by z, which is like the z-score for that randomly selected flower. And the 17.5 got replaced with its corresponding z-score, which was 0.91. So at this point, we need to find the probability of z being greater than 0.91. And we are now on familiar ground because this is what we talked about last time. If you understood what we did last time in section 6.1, you know exactly what to do from here. If you're using the table, you go to that table, table E, you look up where z is 0.91, and the number you find is 0.8186. And if we wanted the probability of z being less than 0.91, that would be the answer. But instead, we want the probability of z being greater than 0.91. So our answer is 1 minus the number from the table. 1 minus 0.8186 is 0.1814. So that's the probability. 0.81 or 0.1814, about 18.14% of the flowers are more than 17.5 inches tall. And so that's the probability of getting one that's more than 17.5 inches tall. Now, the second approach we could take would be to use a graphing calculator or calculator app or something like that to answer this question. We would have to ask it for the probability of x being greater than 17.5 when mu is 15.5 and sigma is 2.2. So let me show you what that looks like. So on a TI graphing calculator, like a TI-84, I'm going to go to the distributions menu. Remember, I push second and then the button that says DISTR above it. And I'm going to select normal CDF, the second thing on the list. And I'm going to give it my lower and upper limits. Here the lower limit is 17.5. And the upper limit is, well, really it's infinity, but I can just put it in some really big number like 9999. We want x between 17.5 and all the way up. So the lower limit for these flowers is 17.5 inches, and the upper limit is practically infinity, but we can just put in some really big number. And then we put in the numbers for the mean, 15.5, and the standard deviation, 2.2. Go down to paste, hit enter again, and we get our answer, 0.181651, and so on. And you may have noticed that's not exactly the same as what we got when we used the table. We got 0.1814 instead of 0.18165. And that's because when we used the table, we rounded that z from 0.90909090 to 0.91. So this that the calculator gave us is slightly more precise, but they're so close that they're both close enough. If you had a different model of calculator or it was set up differently, then when you select normal CDF, you might just get the word normal CDF. Then you would put in 4 numbers. The lower limit, 17.5, comma, the upper limit, 9999, comma, the mean, 15.5, comma, the standard deviation, 2.2. And it will give you the answer, 0.18165, and so on. If you're using the Desmos graphing calculator app, either online or on your phone, go to the Functions menu, go to Dist for the distributions, select Normal Dist, and this time, while we're inside the parentheses here, we need to give it the mean and the standard deviation. Right now it says the mean is 0 and the standard deviation is 1, but I'm going to change that so that the mean is 15.5. Then I'm going to hit the comma and put in 2.2 for the standard deviation. And now I'm going to check the box where it says find cumulative probability. In the blank where it says min, we can put in our number 17.5. And in the blank where it says max, I can see a little faint infinity symbol, and we're just going to leave it there. We're going from 17.5 on up to infinity. And so the number that shows up in the little box there is 0.18165 and so on, just the same as what the calculator gave us. There's also that online normal probability tool that I gave you a link to in Canvas. So if you want to use that, make sure normal distribution is selected. And we're going to put in the numbers for the mean and the standard deviation here. The mean was 15.5 and the standard deviation was 2.2. And we want the probability of x being greater than 17.5. So I selected the one with probability of x being greater than blank, and I filled in the blank with the number 17.5. Now I'm going to hit calculate. It showed us a graph with the region that we were talking about shaded here, and it gave us the answer in red here, 0.181651. So I'm going to stop this video here and come back in the next video, and we'll work through some other examples. And don't forget, we still have that second kind of problem where we're going in reverse. Instead of starting with a range of values and finding a percentage or a probability, we're doing it the other way around. So that's coming up.